Okay. So, could you introduce you? Yeah. So, shall I start now? We have to ask Michelle. Yeah, good. Okay. Just 1 second. Okay. I have to start. Okay. Introduce you. Sorry. Is it also, you we send a link to others too, or? That's okay. So, when, oh, okay, is it recording? Thank you. Okay, is it okay? No, that's fine. Okay, so welcome everyone for the GRACE series lecture. And we have some of the members of the GRACE series team present here. And I'd like to thank all of you all for attending. Today, we have a very special guest speaker. She is our own UT Dallas PhD, former PhD student. And in fact, she was my PhD student, so I'm very proud of her. And she is Dr. Parveen Pallabi, or Dr. Pallabi Parveen. And Dr. Parveen was my student for master's and also for PhD. And she did her master's thesis on applying neural networks for face recognition, right? Machine learning for face recognition. And then she was working for Texas Instruments at the time. And then she came back and finished her PhD in the area integrating data science and cybersecurity. And she finished her PhD such a long time ago, 2013. Oh gosh, it's almost 10 years ago this October, right? Mm-hmm. Yeah. And so she worked for, I think that consortium, that research lab from VMware and BCE. And then she joined, she's an AT&T, and she's principal big data software engineer. Principal big data software engineer. And her work is in, again, in data science, big data, and she also works in cybersecurity, so best of both worlds. And so she's going to talk about, right, data science for cybersecurity. So you work in the Chief Data Office. Yes. Okay, so that's very good. And so welcome, Dr. Parveen, back to UT Dallas. And she's been here for quite a few of the GRACE lectures over the years. So thank you very much, and let's give her a hand. Okay, so it's all yours now.
Thank you, Dr. Bhavani. Thank you, Dr. Professor Bhavani. So Dr. Professor Bhavani already introduced me. I'm Pallabi Parveen. I'm working as a principal big data software engineer at AT&T. And today I'll be presenting about data science for cyber security. So first, I will talk about my personal and professional journey in computing fields. Next, I will discuss about why we need big data and data science. Then I will talk about some of the cybersecurity research that I have done at UTD. Next, I will cover some of my research work, which we have done also in AT&T. And last but not least, I will cover how does it look, the women in workforce at AT&T. So, my background, how did I get here? I was born in Bangladesh, and I always aspired in my life that I want to be a data scientist. So, not only data scientist, I want to be a scientist, and also also want to be an engineer. And that is why I decided to study in computer science department, and I completed my bachelor degree from Bangladesh University of Engineering and Technology. During that, I did not end my journey there because I was always aspiring that I need to do some higher study, and which I always think that I should do it abroad. and very particularly in USA. So finally, I was able to come to USA, and I was very fortunate to pursue my degree in computer science for master's and PhD in UTD under Professor Bhavani Turshingam's supervision. She was a very well-known researcher in the computing field, and she is very actually caring for your needs, and also she many times in many ways she inspired me, encourages me, and gave me a lot of motivational speech, so which helped me to proceed where I am now. So now, in the meantime, so while I was pursuing my master's degree, so in the meantime, I landed for two internship, which is on Cisco and also in Texas Instrument. But during this internship, I get a lot of visibility about the corporate worlds, which is, I think that every students should get this opportunity for their career development. So that's shaped my career a lot, I believe, and also like during my research work in UTD and both the corporate world experience, that's helped me a lot. So next, once I finished my internship there in Texas Instrument, next I joined in Texas Instrument as a full-time embedded software engineer. But while I was working on camera device and sensor on Android phones, so for embedded software development task, I mostly use C languages there. And you need a great deal of kernel, Linux kernel experiences if you want to work in the embedded software development field. So that is one thing, keep it in mind. Next, I was working there, but my actually keen interest was in artificial intelligence. So I mentioned that I always had an ambition that I want to pursue some research work and also in the artificial intelligence field. So in order to fulfill my dream, after 2.5 years of working in Texas Instrument, I again came back to UTD to pursuing my PhD. So I also like to acknowledge my parents, like who also inspired me for coming back to UTD and finish my PhD, and also my family members, spouse also, I will say. And next, while I was doing my PhD, my dissertation title was Insider Threat Detection Using String Mining and Big Data Analytics. So I will cover these things in later slides, like how what we did in that project. But before that, I would like to also mention that after finishing my PhD, I joined BSc, which is actually later renamed as Dell EMC, or known as Dell EMC. So there I have been working as a senior software developer in cloud computing on Converse infrastructure. So I was developing actually some microservices, which is Spring Boot microservice mostly, while using Cassandra and Elasticsearch as a backend storage. And also we were collecting some operational metrics from different layers like storage and compute system, VMware, and also from the network layer. So those are the things that we did in VC, and it was actually a lot of fun there. I learned a lot in the computing, in the cloud computing, and also in the converged infrastructure area. So finally, I decided to join AT&T as a principal big data software engineer in 2017. So, and here actually we are now working mostly related to AI related work, which is artificial intelligence related work, and we are working with many data science in our team member. There are many data science there. There are many data engineers there also, and we collaborate with them, and continuously, we are working on some cybersecurity and using big data approach, which includes like Spark, Scala, and those kind of things. And also for machine learning tools, we use Databricks, Hughes, and also we use Azure Cloud for our infrastructure. So here in AT&T, we have a huge amount of network traffic data, and we are continuously thriving to find threats and anomalies within these traffics. So we use different machine learning techniques, deep learning, and statistical model to find out any anomaly in the network data. As I mentioned, I joined AT&T and I'm working in a working in a fraud team. So we are trying to mitigate any fraudulent activities within our team and are working under Chief Data Office, where actually I can give an example. Like if you have heard about the SIM swap, like nowadays a lot of persons, a lot of things are happening. Like suppose a fraudster came and he knows your some of the account information. So what they can do, they can talk to the agent and then they can convince that okay, my SIM is broken or SIM is lost. So maybe we can can you do my SIM swap for me? And at that some point, they make it so convincing and giving lot of information, internal information which they have already. So they were able to solve the SIM. At that point, what happened? Already the SIM swap happens. The customer loses his contact, all those information loses, and by the SIM swap, it can take all the information of their bank account, and also they have a cryptocurrency, all those things, all information is gone. So they have all, they get access to all those information, and by that time, there will be huge loss incurred for the customer as well as for like the corporate world also. So this is so this is where actually we are looking at like stopping the SIM swap fraud acts and other fraudulent activities. Not only that one, there are some other fraudulent activities is happening also. So we are continuously looking at our we are continuously collecting the streaming data and looking at our data set, and we are using machine learning model, and also we are using some kind of rules to find out like before any fraudster can come between us and just take access of everything. So we want to stop those kind of actions. So this is what actually we are doing at AT&T as of now. Next, about me, I have already covered that what is my profession and what is my education. So with regard to the publication, I have done multiple publication while I was doing my PhD in UTD, but also from AT&T, I did two publication in IEEE. And also there are two journals also I have done on for my with regard to my publication. With regard to activities, I am heavily involved in the women in AT&T. Also, I'm involved with the innovation network in AT&T. Besides that, outside AT&T, I also participate Global Women in Data Science and also in the second IE Women in the Service Competing workshop. So these are the activities I am currently involved with. Next, this is my journey about like how I shape my professional career and my personal life. How in between I have to balance between all those things. So now I would like to talk about the data science. So most of all we know that data science. Many of us have a because when I have a wrong impression about data science, like I thought data science is all about machine learning, but actually data science is a intersection between three areas, which is like actually subject matter expertise and also math and statistics and machine learning. So I can give an example, like suppose we are looking at some medical data. So what, as a computer science and engineer, I will not be able to understand the medical data there, right? I need someone from medical profession to let me understand what is the data means, how can I interpret the data better, and what are the features that I need to look at for this particular problem. So that's why we need a subject matter expertise always when we are doing some work on data science. And then second, for the math and statistics part, if you want to look at the data, like we need to know the distribution of the data, how the data is distributed, and what kind of distribution or what kind of sample we should take from there, what kind of confidence level we should expect from that data. So those kind of things is part of the statistics and math groups. And next, machine learning, we need to like predict data, we need to have a model, we need to have generated features. For that we need machine learning knowledge for generate features and generate model, and then we predict as well. So these are the three combination can make a data science work successful. Now, here I will cover now, during my PhD, I have done multiple researches, and we have multiple papers on that. But today I'll cover only one topics on that. So this is one we have used in our cybersecurity research at UT Dallas, where I use, we can see here, we use unsupervised sequence learning and ensemble-based streaming analytics. So for that, initially we address some we look at some data set, which is actually a sequence of commands that we took for our research purposes. And the sequence of commands are all in Unix. And then we divided the sequence of commands into multiple chunks here. I don't know. Yeah, this multiple chunks. We divided the sequence of commands into multiple chunks. Once we pre-process this data, and then each Unix command, we convert it, index with some Unicode, and then we apply the unsupervised sequence learning, which is Lempel-Zip-Welch algorithm, and on top of that, we use compressed dictionary. After that, we use ensemble-based streaming analytic, where we use ensemble of models. We use actually three models at least there. So when a new chunk, I will describe details about this unsupervised sequence learning in the next slide. But here, in a nutshell, we use ensemble of models, like we use three models there. Whenever a new chunk arrived, like for a training purpose, so we always update these ensemble models with a new chunk based on the accuracy. So it was like, so we are keep updating our ensemble of models continuously with the streaming of data. Now, when we test chunk came, like we want to, for the testing purpose, when you have a test chunk, we need to pre-process that data. So we pre-process same as the training data. We index that with Unicode. Each command we index with a Unicode, and then we use the ensemble of models. Then we take a majority of voting from the model. If a majority of the model says that there is an anomaly in that test chunk data, then we consider that as an anomalous data. So this is a like a architectural design of like what we did for this work. So next, I will cover, like I mentioned, that we use unsupervised sequence learning, which is a Lempel-Zip-Welch algorithm. So I will cover like how did we derive that one. So here, actually, I mentioned that we have a sequence of commands, like Unix commands. And how do we say that this is a normal behavior? When we see that there is a repetitive pattern, then that we consider as a normal behavior of the user. Like the user, suppose we take collection of 7 days of data. So we see that user is working in the same pattern every day. So that would be a normal behavior pattern, and that normal pattern is considered as a normal, like a normal repetitive sequence of commands. Now, if we see a sudden deviation from that normal behavior, then that raises an alarm and indicate an insider threat detection. As for an example, suppose we see that one person suddenly start downloading a huge number of files at the midnight, which is he doesn't do that usually. So from there we can see that okay, this might be this can cause or raise an alarm for indicating at an insider threat. So now, so find the insider threat. First, we need to find a repetitive sequence of commas that is normal. And for that, we have two challenges. Like when we say that repeated sequence of commas, we don't know that what is the length of the sequence of commas should be. So we don't know ahead, like what would be the length. It can be 4, it can be 5, or it can be any length. So that in order to address that challenge, we use here Lempel-Zip-Welch algorithm here. And then for the second challenge, once we use the Lempel-Zip-Welch algorithm, I will show what does it do. And we generate all the possible patterns out of from the normal or the sequence of commands. Then the size of the dictionary got bigger. And that is, in order to overcome that, we use a compressed dictionary after then. So here is an example. Like if we see there, here, these are the lift. So what each of the word represent, as I mentioned, that we convert each Unix command to a Unicode, which is suppose L. So L represent a command. It can be CD to change the directory to something. Okay, and then I is another command, which is like maybe a copy a file, some Unix command. So these are the all command, and these are all repetitive patterns that we can see within a user profile. So we see that, okay, he's doing the same thing for 7 days, this lift. Okay. So this is the normal behavior and normal pattern of his work. Now from there, using LGW, Lepers Deep Wells algorithm, I'll not go details about how does it work. If you have any question, feel free to ask me later. So with this algorithm, we generate a multiple different combination of pattern. It can it can have LI, or it can have IF, repetitive pattern, or it can have a FT, or it can have a lead. So all these kind of pattern we can generate from out of this. But and we actually, you can see that there's a length. We don't know the length ahead, which I mentioned that is a problem. Like we don't know what is the exact length should be for this repetitive pattern. So it generates multiple combination with all possible pattern and length. And then also it, as we associated with each of the pattern with some frequency, like how many times it has been appeared during this whole session. So
So
after
after
then, we
10,
use a
use a
quantized
quantized
dictionary. So for quantized dictionary is actually a lossy compression. So from here we extract only that pattern, which is the longest pattern with which is as a multiple frequency also. So we kept only here. We can see that we kept only the left. It can be even different patterns we can keep, but here we see that we can just keeping this pattern. So this is a normal repetitive pattern that we can see when a user profile for if we take a profile for 7 days, then we can see this is a normal repetitive pattern for this kind of. Now, next, for the context dictionary, the way we do the lossy compression, like the way we extract the compress the dictionary, is like we take the longest pattern multiplied by with a frequency, and we take the maximum of that one. And we kept only that one as in the context dictionary. So we can see in the previous, we just only we take the longest one, and I didn't show here the frequency, the weight. Each pattern is associated with some weight. So we take the maximum one, which has the maximum value multiplied by weight. We kept that as in the our context dictionary. Now I'll cover some of the cybersecurity research that we did in AT&T, but I'll not cover many of them. Just only I'll cover those we have published in the IEEE paper when we are working in AT&T. So, but we definitely doing lot of things behind that. So here, actually, we are looking at some DB scan, which is I think you already have known what is DB scan, and it is a density-based clustering. It locates regions of high density that are separated from the on another by regions of low density. So you can easily identify some high density region compared to the low density region. So the DB scan, we have three different concepts. We know like what is noise, what is core, and what is the border point. So in DB scan, we use actually two parameters. One parameter is the number of points. Minimum point should be in one region, and also the radius of the region. So which is epsilon, we neighborhood epsilon. So the point which it has more than a specific number of points, minimum points within epsilon neighborhood is called the core point. And the border point is, this one is a border point. It is within the region, like epsilon radius, but it doesn't have the minimal number of points of data there. So this is the border point. And noise is obviously it is outside the region, which is called we called as an outlier. So next, our proposed approach that we published in IEEE and while working on AT&T, we have a we have a continuous data stream, like we have a continuous network flow of data. Now the problem with DB scan, I don't know whether you already know that is the training time is a very like it has a very high training time. So in order to tackle that one, it's not very feasible for a large data set, and the training time is very high. So in order to tackle that one, we continuous data stream, we partition into multiple chunk. So what we do, we apply the DB scan. So as we partition into multiple chunk, the data set size of the data set is now smaller. So we apply DB scan on each partition, and then from the DB scan, I showed it earlier, like how can I find the outlier. So we generally find out the outlier from there, because our main goal is to find the anomaly within the data set. So we need to find some fraudulent act or some outlier there in the data set in order to mitigate that fraudulent acts within our network flow data. So we are looking at the outlier. So we have each partition, we generate some outlier. Then we combine that outlier again and we apply the deviation scan on top of that and find the global outlier. So while we are doing this thing, because we are looking at more at false negative, we don't want the false negative. We want we can identify the fertile lab as soon as possible. While we are compromising some false positive here, in this diagram you can see that what happened when we partition it. Like suppose in the case one, there are two clusters. We partition in the middle. There is no outlier. It doesn't have issues, so we are fine. But in the case two, there are three clusters there, and if we partition, like because we partition our data stream into multiple chunks, if we partition in this way, then the blue cluster will think the black one is outlier, and the red cluster will think the black one is an outlier. So we'll have some false positives there. So it increases our approach increases false positive, but we are okay with that because we are more concerned with the false negative. Here also another case like where the red cluster thinks that the black one is the outlier, but actually this should be within the blue clusters. So doing this partition this way, we have a high false positive, but we are okay and we okay for our purpose. So this is the algorithm that we used for our partition error uh, outlier detection. Now, also another work we did in AT&T, it is also published in the IEEE paper. So we use, for our training purpose, we use autoencoder. And then for our test data, we obtain some reconstruction error per record instance against this model. Once we get the reconstruction error, we actually feed this reconstruction error to an exponential variable probability density function and generate the score. So why we use variable distribution instead of normal distribution? Because like actually our data is mostly skewed. It's not like a normal distributed data. It's a very skewed data, and variable distribution performs well on a skewed data set. So we feed this reconstruction error to an exponential variable probability density function and generate the score. And here we can see that if the score, like if in the here we see if there is no squid, like is something is not there, which is like we don't want, which is outlier, is not there, then the score will be between like 0.66 something. But if there is outlier there, the score will be higher. And if the score is higher, then we consider that one as outlier. So this is another research that we did on in AT&T, and yeah, and that's was like we get a good performance on that. So today, actually, I will cover ChatGPT also. This is the cutting edge technology. We are using ChatGPT in AT&T also. Recently, we have been starting working on ChatGPT, and with lot of like we have lot of customers data, conversation data, like because we have a conversation bot there, so we can collect a lot of chat data and then apply the chat GPT. We can take the summarize using the chat GPT. We can take the summary of that chat and then feed into a model, and then we can use that model for our finding some fraudulent act within that like AT&T bot conversation with the like between the conversation we can find some fraudulent acts. So here chat GPT initially, I would say like ChatGPT, it's use a large language model, which is actually a type of neural network. It also uses a transformer architecture, and it predicts which word should follow the previous. So it find a what would be the next word in a sequence. So for ChatGPT, mainly we are using it for sentimental analysis, and also we are using some kind of text extraction and summarization. Maybe we can use for its question answering also. So there are different approaches, that different way we can use the chat GPT. So here there is an example. Yeah.
So, so you're using ChatGPT for what applications? Anything to do with security?
Yes, we are doing ChatGPT for like we have a bot. It's continuously be generating some chat text for us. So now we are trying to suppose like what I mentioned earlier that we have a SIM sub apps. So before the symptoms of apps happens, what happened? The fraudster, they try to convert, like try to talk with the agent, and then try to persuade that okay, this is my account information. They hack some of the information. They say this is my account information. This is this thing. I just forget. Give me that things, and that way they just try to persuade and then get the persuade them to make the symptoms of happens. So what happened? We have those kind of chats with with us. So once we use that chat GPT to summarize that chat and feed into a chat GPT has a model also, like they can generate the embedded vector. We can use for classification clustering. We use that one. Then feed into that, we can identify like within this text, maybe there are like when a new chat come, chat text we get the new chat text, then we can feed that in that model and we can find out okay it might be a fraudulent acts there. So that's we are trying to do now at this point. And there's also some other things also we are trying to do because like our AT&T has a lot of HR related documents also. So it would be easy like if we feed our HR related documents there, then it will be easy for like anyone go to our AT&T chat and then ask some HR related questions. They can immediately get the answer from the chat GPT. So, but in order to do that, we have to feed the documents into the ChatGPT and learn, like train our model there. And once that is done, then anyone can go and ask some information about the age-related questions. No. No, no, really. So these are the thing actually like different kind of things we need to we are doing. Like it's we are exploring actually at this point. We are not to an end, but we are exploring. So here, there's an example like ChatGPT. If you feed this prompt, like ChatGPT has a prompt, you have to feed that prompt. So what happened underneath ChatGPT? It is a large language model. And what is a large language model? It's actually nothing but some embedded vectors, like which is a encoded facts. Some we feed a lot of facts there, but it is embedded form. So when there is a prompt there, we ask this kind of things, and then it breaks into token, and underneath those tokens is fed into this LLM, where it will have, it is underneath the neural network, there are a lot of words. Then after then it will generate what each for each token it will generate what would be the next token for that, and that way it can respond to our query. So this is the way ChatGPT works here, but how we can improve that ChatGPT? So when we ask, suppose that we ask a question and then we get a feedback. But in order, instead of asking a question, we can also, as a prompt, we can feed a fact there. So we said, okay, I know these things. Maybe I don't have the example at this point, but some facts that you can feed into that LLM from your knowledge base data, and then fine tuning the LLM, fine tuning the orange one more. So that way we can inject additional knowledge to the chat GPT and we can fine tune it and then we can use for our customized purpose. So ChatGPT, there are a lot of open APIs there you can use. I there are yeah, you can find it all the open APIs that we can use to feed that facts into the ChatGPT. So there is another example here, like instead of sending the fact uh, into the model, we can also use from the knowledge base, we can get the training data here. So we can get a sample training data from the knowledge base and feed into the this ChatGPT fine-tune model. And with help of the prompt, we can further tuning it, and we can make that facts more like more correct for us. Like sometimes the all the facts that is being given in the chat GPT are stale, so we have to like retune or fine tune these facts and make it more customized for our customers used. So these are the chat GPT that we can use. Um, Okay, there is, here is an example like how we can do it. So suppose like we have a open API. Okay, now we have a question. So what we do, we ask a questions, send it to the open API, and it send us back some answers. But now we don't want that one. We want to further tuning it, and we want to enhance the chat GPT. So instead of doing that, what do we do? we have a text, long text. So we have a big chunk of text. So we divide that text into small chunks, and then we fed it into this. From that chunk we will generate some vector database, and each chunk will be indexed by a chunk embedding vector, and then we'll keep it in the vector database. So we from that is we divide each chunk. Each chunk will represent a vector, and we'll keep it in the vector database. Next, what will happen? Now we have a question. We will actually convert it to embedded vector also, that question. And then from this chunk database, we'll get that corresponding chunk that represents this question. And we found taking that chunk as embedded vector and the question as an embedded vector, we can feed to it to chat GPT, and then further tuning it and get a better response out of it, because now we are feeding it with more text and with the questions, so it can answer better way than what initial ChatGPT would do that. So this is the different many different way we can enhance the ChatGPT. Um, so ChatGPT in the future could interpret company data like sales figures, marketing responses, and generate short narrative text for target audiences. And also it can enable quick and easy to read reports. This is what also we are doing at AT&T, trying to do it. Uh, Now, how does it look, the women workforce in AT&T? uh, Among all the employees, we see that one third of the employees are not one third, actually one fourth of the employees are women, and among them, 22% are in the STEM role, and 35% are in the manager role also as well. As I mentioned, that I work in a CDO chief data office at AT&T. So what we do, our office they do combination collaboration of big data automation and data supply chain. So this is what we are doing in chief data office.
So I have a question. These out of these 69,700 women, our 225,000. So that is about
One fourth.
more than 20, more than 25%. But what roles are they doing? Are they in STEM? When
Yeah,
you say
25,
20% in
20%
STEM,
in the STEM role
okay,
and
that's
35% on the managing role.
35% managers at
Yeah,
AT&T.
yeah.
That's a good number. Yeah. How many like vice presidents? There must be, right?
We have few vice president as a woman, but we have also
Okay.
multiple.
Okay, please continue.
So AT&T cybersecurity and data science. I would not mention everything what we are doing, but one is like this is the area that we are working on: fraud detection and visualization, and also some of the event prediction. So these are the many areas that we can work in. AT&T is working and with related to cybersecurity. So for the personal development, for you all, I would recommend.
Are you working at the research department in the
No, actually, I'm not in the research department, but we have like besides the work, we do some research work also as well.
So
So,
the
but
research department is where? That's in New
it's in
Jersey.
New Jersey.
New
It's a
Jersey.
lab there.
That's
We
the
are
Bell
not
Labs,
Bell
right?
Lab, yes. We are not in that group actually, but we in our team we have the flexibility to do some extra like research work. Our manager encourages that.
So this work that you are describing, are they going to be converted into products or you are develop prototypes and then send into a product division?
For the ChatGPT now, it's just like a prototype. We're not haven't have done any product yet,
Mhm.
but the other stuff that I covered, we have some product.
In your team.
Yeah, yeah.
Oh, okay.
So now the personal development. So I would recommend for all of you take some training and certification, and that you can take from Coursera and Udemy, a lot of places there. It will help to boost up your resume for like any if you want interest in your corporate world. And then there's some nano degree also you can take, which is like it's like a 6 months course, nano degree, and it's very
Which says I couldn't get
nano degree.
nano degree
Yes,
in what?
in different fields, like whatever you
So
like.
what do you
Like
mean for nano?
nano means like it's a 6 months,
It's a
6 months
short.
short degree, like nano degree. Yeah. So and then you can take some different you can go to different university. They provide PGP program, which is like postgraduate program, which is also a 6 months course, and it's on data science, analytics, NLP, lot of things they're covering there.
I think this is really good for especially some of the older
Yeah,
people
older
to
people.
get their
But even I
deeper
encourage
skills.
the younger people too, because when you do these things, you get a lot of knowledge,
Yeah.
and you can, when you with that knowledge, if you get into a corporate world, it will help you. So yeah,
Yeah,
you are
you're
right
right
in a
in a
way
way.
that it's like in the advanced stage we should take that one. But
Yes.
if anyone can take it early, that will be
Yeah.
also good.
Maybe I should do. I was taking, FNMO forensic certification and CISSP, and then I could just restart it. Yeah.
So
Because
then
it's always good to keep the mind active.
Mhm. Then I would recommend some cloud certification, because heavily everybody is using like AWS, Azure. So whatever you can take, some cloud certificate is very good. And most of all, if you're in machine learning, then Databricks is very good for machine learning platform. So you need it's like underneath Databricks use Spark, and it's for if you are using big data concept, like you have a big streaming data, all those things is very easily you can use with the help of Databricks, you can easily tackle those kind of things. So Databricks also play major role in machine learning techniques. So, and this in my presentation, if you have any question, feel free to reach out to me. And now there is a survey. So if you click on that survey link, and there's, I think, prize involved in that survey.
So before that, Dr. Kennedy, should they ask questions now or later?
Um, yeah, so they should put that in their phone, and then you'll have, the results. And meanwhile, everyone can ask questions. So,
So what, so in this case, we take with our phone, take a photo.
yeah,
And then,
and then it will, they'll fill out, take into a survey. They fill out the short survey,
okay.
and then they'll be eligible for one of our three prizes. But meanwhile,
The questions, then anyone has questions? Dr. Oh, there's a question. Yeah.
So I have a question about cloud certifications. So like, is it good to like get them early on in your career? Like, does that help to like move to different jobs? Or like, I've heard that people get certifications with cloud once they actually work there, and then they can get promotions after they get certifications. So is it helpful for like new grads and also like?
Definitely, it's helpful, because when you take the certification, you get a lot of knowledge there, right? It will help you in your work also as well. So I would say that not for the promotion, but for your own benefit, understanding those kind of things more. Because when you take an exam, even anywhere you take an exam, you just prepare yourself more, learn more on that, right? So that way you can have a better knowledge on those kind of things. Whereas when you learn by yourself without an exam, it might just like you can overlook something. So, yeah. And yes, please. And also, like in our AT&T, like they encourage every year we take some certification. So it is like kind of mandatory for us now. Like at least we have to take two certification, or at least one certification each year.
And they will pay.
Yes, they for the certification exam they pay for. Preparation we have to do by ourselves.
Okay, so can you give an example of the certification?
Yes, suppose for the we have taken Azure certification, Azure fundamental, then
Azure.
Azure data engineering, because we are using Azure, so they encourage us to take certification on Azure. So we get data engineering, Azure certification, data engineering, and then initially we have to take Azure fundamental, then data engineering, and then also there's data science in Azure. That another
But
certification.
preparation, they will pay. You have to pay.
Preparation, actually there are some lot of online materials. We can go and just read those materials. For the exam, it calls some they will pay the, I think for the first exam they will pay for that. But if you
Typically,
If I fail, then I think then in that case we have to do from our own pocket. So yeah. And then also Databricks has also certification because we are taking Databricks.
Yeah.
Yeah, so we take data science in Databricks also.
So Sarah had that question.
Yes.
You mentioned large language models and chat
Mhm.
being used with human resources. That's terrifying. Because large language models are known to hallucinate, but be very convincing
Yes.
when they give wrong information. So what fail safes are your team
Is-
thinking about?
we had actually in the prototyping that I mentioned, we didn't have a product yet, but what we see that if we feed a lot of documents and then I showed you the prompt. So if we like change our prompt in a different way, it can answer the things in a different way. So we have to be careful like what kind of prompt we are sending, and we have to train. So once we are at that point, like training a model and we're confident enough, then I think it should not do like what you're thinking. But yeah, still there is some like it can give you a wrong answer sometimes. Yeah, that's true. Yeah, yeah, very confidently. So there is always like some drawbacks there, but yeah. But I think, but training it more and more, fine tuning it more and more, it might be getting it would get better. And the prompt actually very important. We can shape the prompt in a many different way, and that's because of the prompt, the answer will be many. It answer can be in many different ways.
Question, but about AT&T, I thought it's in the telecom industry. But these things, how do they fit in that? This
In
is
AT&T, it's a we are a telecom company, but like we have lot of things under the hood. Like it's not only network data, like we have conversation